So Pramod and Amit, so what is your visibility? How much do you know about this service?
Amit, are you
Yeah,
there?
yeah, Vishal. So like from my side, I know the API, through the API I was calling, and
Okay.
yeah.
Okay, so you know the API that calls and you also know how it works, right?
Yeah, I know.
Okay, fine. What about you, Pramod?
No, sir, I'm not much aware of this.
Mike.
Oh, okay. Pramod, you're using Shreya's mic or what?
Yeah, share is Mike.
Okay, yeah, cool. Now tell
I'm
me.
not aware of it. That's what.
Okay, fine, cool. Yeah, so coming to Aligner then, I mean, I'll just tell you how it works and will also do some code walkthrough. Okay. So in the meantime, let me just open the documentation as well, which okay. Amit, have you gone through the documentation as well?
No, I didn't gone through the documentation. So like I know only the API because like Navneet told me about the APIs thing. So yeah.
Okay. Translator. Why do I not see Aligner? Content as well. Okay, sentence aligner. Cool. Looks like we have it here. First is your local setup with workflow without workflow manager and uploader. You hit a direct API. There's no line. I'm just looking if this document because Ashwin created this document, so I'm just kind of brushing whether this is the updated one or not. Sort of line jobs. That is the get API. Sentence align. Story XT files. Okay. Respond. Task start. So you have this, and then you have this. 100 job details. But technically, this should come from Okay. Looks like this is it. You have this and you have a workflow alignment. If you want to make a call. Okay, cool. I think yeah, this was just going through. So it looks like this is updated enough. So we should not have any problem. All right. So basically, Aligner is a tool which is used in corpus creation. Okay. So what do you mean by corpus creation? It's basically when you want to create corpus for our parallel data set. So you guys might already be aware that Anuvaad has created the largest parallel corpus, right? So largest parallel corpus, I think we have over 200 million sentences curated. Of course, there are from multiple resources as well. But yeah, Anuvaad, basically the data set that is hosted on Ulka, which comes from various sources, has around 200 million pairs of parallel data set corpus, which is like the largest openly available parallel data set. Okay, so that is one feat which Ulka has achieved in a very short period of time. So now the same process of creation of parallel corpus can be done in Anuvaad as well. In Anuvaad, we use this tool called Aligner. Okay, so why did we need tool called Aligner? Because initially when we were developing Anuvaad, our NMT model was not that I mean, it wasn't like a very advanced model as such. We had trained it on the data that we had, and then the model was learning on the go. So in order to do two things, in order to make parallel corpus available openly for a very larger audience, and also to create like a very comprehensive data set that could be used to train our models, we came up with this tool called Aligner, where you pass two text files with the jumbled sentences, and Aligner would take those sentences, align those sentences, and then create like a aligned output. So the input would be two text files, say English and Hindi, but those would be a set of sentences only. Okay. So two files with a set of sentences, one in English, one in Hindi. You pass both of them to Aligner. Aligner actually aligns these sentences. What do you mean by alignment? Alignment is basically finding the most similar sentence in the target file to that of the sentences of the source file. Let's say you have two files. One is an English file and one is a Hindi file. And the English file has like around 100 sentences and the Hindi has around 100 sentences. Now you know that both of these are translations more or less, but you don't know which sentence of the English line corresponds to which sentence of the Hindi file. Basically, you don't know, you don't have a similar matching sentence pairs. Whereas this is a very jumbled input, right? So you take this jumbled input, send it to the aligner pipeline, and the aligner will come back to you with a aligned output. So that was the reason why we came up with Aligner, so that I mean this is how the Aligner was designed, and then this data that comes out of Aligner could be used for multiple purposes. Okay, so this is like the basic idea behind Aligner. Now, so how do we do it, right? How do we do it? So Aligner is basically a Python service. It's also a Flask Python application only, which has APIs. And then those APIs are again, those APIs basically accept TXT files, two TXT files. One is an English file and another one is a Hindi file, or basically two files of two different languages. Okay, it could be any two languages. Now those files are taken and then those are sent through an alignment engine. Okay, so initially our alignment engine was Laser, which was developed by Facebook, and then we moved it to Labse, which is a Google model. Now, why did we do that? So basically, Laser was being used through an API, as in Laser was hosted on a separate service and our Aligner service was hosted on a separate service. Aligner used to connect to Laser via APIs. Now, this introduced a delay, right? Because an API call always needs a network call, request response formatting, and all of that. So, with an API call that is made for every sentence of the source, we had essentially introduced some amount of delay in the process. Now the goal was to mitigate this. The goal was to ensure that we perform alignment at a very higher accuracy and also at a higher efficiency. so that we don't waste much time in the alignment process. Okay. So one problem with laser was it being used as an API. Now the question was, why couldn't we use this as a library? We tried to use it as a library, but we couldn't do it. I mean, it didn't work. Basically, when we were trying, we did not find any libraries or any suitable packages that could, kind of ensure that laser could be imported as a library and then used inside the code. So the most efficient way, based on how laser was designed, was to use it as an API. Okay. So you run laser in a different Docker container on a separate machine, and then you run aligner, and then you make a API call. Now the problem with laser is that laser is a PyTorch based model. Okay. Now because of that, parallel processing is a big problem. Okay. So PyTorch by design is not meant for multi-threading, multi-processing based operations. Because of that, whenever you want to make any multi-process or multi-threaded operation in laser, it would always fail. Now, what do I mean by that? Let's say I have 100 English files to compute, right? So I have a file of Hindi. In that Hindi file, I want to create an alignment for my English sentences. Now, if I have 100 source sentences, the best option is to do it parallelly, right? Make like 100 calls, trigger like 100 threads, and then all of them, let them compute simultaneously, and then just kind of find a result, right? So this is the best way. But then when we tried to do it, laser started breaking when the order of parallelism increased 10. As in, if you started running more than 10 parallel processes, aligner started breaking. Okay. Breaking as in it went out of memory, it had process related issues, and then it just used to shut down. So that kind of gave us an idea that laser, since it's a PyTorch based system, as expected, will not perform well in a multi-process or a multi-threaded environment. Now the problem is there are two problems now, right? One, being used as an API, which is essentially adding some delay in the process. Second, not able to be leveraged into a multi-processing based alignment engine, because of which again there is a much more delay, or basically there is no room for optimization. So because of these problems, and one more reason was laser was not that well trained as compared to LabSafe. Okay. So as far as I remember, laser is not well trained in Kannada. So if you want to actually do an alignment between, say, Hindi Kannada or English Kannada or anything of that sort, laser will not perform well because it's not well trained in Kannada. So that was one more problem. And the corpus that was used to train laser was also not as diverse and as big as that of LabC. So because of these multiple problems that we had with laser, we moved from a laser based alignment engine to a LabZ based alignment engine. Okay. Are things clear till now? Any questions, any doubts? Especially Pramod and Amit, because you guys will be taking care of this module. So yeah, I want you guys to be very clear with this module.
No, Vishal, so far it's clear.
Yeah, it is fine with me.
Okay, cool. Yeah. So yeah, so this is the story as to how we were using laser before, and now we are using LabSay. Okay. Now why LabSay? For the same reason. First thing is LabSay works seamlessly when you use it as a library. Okay. In a Flask-based Python application, if you want to use LabSay as a library, you can just import it right away. There are available packages, and you can just execute it out of the box. I mean, you don't have to do a lot of coding. You don't have to do any extra gimmick on top of it. Okay, so that is one thing, ease of use. Second, LabSay is trained on a very wide range of data set, right? So it has multiple domains, multiple languages, and multiple edge cases and all of that, because of which it makes LabSay a very good tool, okay, for alignment. Of course, I'm not saying I'm not saying that the LabSay is perfect. There are issues with LabSay as well. Even now, when we use LabSay as a what do you call alignment tool in our TMX, we still face issues. So there are cases where LabSay fails to find out that this is the most similar phrase for a given phrase. So LabSay also has its own disadvantages, but compared to Laser, LabSay worked out well for us, and that's why we have been using LabSay now. So if you go into the aligner code, which I'll do a walkthrough at the end of this session, at that time you'll see that there are two implementations. One implementation is laser based, another one is the LabSay based. Both are kept live so that it becomes easy for us to switch between LabSay and laser as and when required. Okay.
So this is about the engine that is used in the alignment. Now coming to the engineering part of it, the engineering part of it is pretty simple. So you give two text files. Okay, both of these text files are first uploaded into the system. Once they are uploaded into the system, a message goes to the Kafka queue, because alignment is a slow process, right? Alignment is not a very fast process. So it takes time for the alignment to happen depending on the size of your input. If the size of the input is large, the alignment also takes a lot of time. So it's directly proportional. So because of that, we use Kafka in between, more like a async mechanism for us to kind of accelerate, not accelerate our operation, but to make it more user friendly, so that the user does not have to wait for the alignment to get over, or kind of wait, because if the process takes a lot of time, then the API call, the response time is also large, because of which you'll again have issues with respect to maintaining a live connection and refresh tokens and all of that, right? So because of that, the idea was to make it async. So first is an API layer where the client hits the aligner with two of the files. So those files are kind of uploaded, and then a message is passed on to the Kafka queue saying a new alignment request has been, or alignment job has been requested. An ID is sent back to the user saying this is your kind of acknowledgement ID with which you can find out, or with which you can track your alignment status. So once that is done, there's a consumer, which is our alignment consumer, which actually picks these files, downloads these files. Once these files are downloaded, we already know that these files contain sentences, right? So before pushing it to the Kafka queue, there is a set of validations that we do. So the validations include whether whether the file contains sentences or not, whether it is in the given size or not, and all of that. Some semantic and basic data sanity validations. Once those are done and the request goes to the Kafka queue, you pick it on the consumer end. Once you pick it on the consumer end, you basically read these files and create like two lists of sentences, right? So one is your English list and another one is a Hindi list. Now these lists of sentences is directly passed on to the Labse engine in order to vectorize. So I mean, if you guys know how Labse or Laser work, the principle is same. So basically they create vector embeddings for your sentence, as in it creates a vector in the 3D space where, so let's say if you imagine a 3D space with XYZ coordinates, whenever a sentence comes, a sentence is converted into a vector embedding. Now a vector embedding can have multiple attributes, right? In a 3D space, usually you just have XYZ coordinates, but when it comes to Labs and Laser, they create a lot of coordinates. I think Laser creates around 512 different coordinates as in 512 different attributes of the sentence, and LabSA does around 1024. So LabSA is much more what do you call, in detail when it comes to the operation. So those embeddings are created. So it's all around 500 dimensional embeddings for every sentence. So now you have a sentence. Now those embeddings are mapped into a 3D space. Now all of you know that vectors have direction, right? So when you have two vectors in a 3D space, it becomes very easy for you to find their cosine similarity. Cosine similarity is nothing but cos theta, right? So you find the angle between the vectors and the range lies between 0 and 1. If the value is 1, then you say that the sentences are similar. If the value is 0, then you say they are dissimilar. Why is that? Because cos of 0 is okay. So yeah, so cos 90 is 0 and cos of 0 is 1, right? So I think sine of 0 is 0 and sine 90 is 1. Similarly, when it comes to cos, it is reverse. So yeah, so basically you find cosine similarity, which is nothing but angle between these vectors, mathematically speaking. If the angle between, so if they are both aligned together, which means aligned together, it means that they are similar. If they are kind of in perpendicular directions, then they are dissimilar. That is the meaning. So the cosine similarity index lies between 0 and 1. 1 signifies they are similar, 0 signifies they are dissimilar. So you do that for every sentence, right? So you take a sentence from your source text, which is your list now. So you have a source list and a target list, right? You take one sentence from your source list and compare it with every sentence of the target list. That is very important. Okay. Now this is exactly why alignment takes a lot of time, because you'll have to suppose you have two files, each of them have 10,000 sentences. Then it's basically 10,000 cross 10,000. It's literally n square computation. Of course, over time it becomes less, because the moment you find a sentence that is similar to a source, you kind of ignore that in your consecutive calculations. But in the initial stages, it's heading towards almost n square computations. Okay. So you take one sentence of the source, you compare it with all the sentences of the target, and then find out whichever is similar. How do you find out? You find cosine similarity between all the sentences, and then you see what is the value. Okay. So yeah, once you find, and of course we have a threshold. Okay. So basically we have a threshold. The aligner kind of divides the output into 3 buckets, if I remember it correctly. It's basically dissimilar, almost similar, and similar. So there is a threshold. Any cosine index value that lies between 0.7 and 0.9, if I'm right, is considered to be almost similar. Anything less than 0.7 is considered dissimilar, like they are not same. And anything above 0.9 is considered similar, right? So that is the threshold. And that is just only because we wanted to not only align the sentence, but we also wanted to identify the sanity of the corpus that is being sent to us, right? The text files that are generated for the aligner to align, we also wanted to kind of gauge the quality of these files as well. So because of that, we generated the output in different buckets, so that on one hand, we gauge the accuracy of the input, at the same time, also provide an aligned output, and also find out as to how much of data is garbage. Let's say, for example, you receive around 100 files, and each of them, like say 100 files, and each of them having like around 1,000 sentences, then 100 into 1,000 is almost lakh sentences, or let's say 1 million sentences, right? If you have 1 million sentences that you're processing, and at the end of the day, you only have 1,000 parallel pairs, then it means that the source of your data is very poor. It's corrupted, right? And based on that, you can make such conclusions as to whether to take data from this source on the next time or not. So yeah, so it's like a multifaceted approach when it comes to corpus creation. So you create this, and once you create like 3 buckets of whether it is dissimilar, almost similar, and similar, you then generate an output of text files. Say that this is like the useless output, this is like the almost similar output, and this is like the similar output. And those are further fed to different engines. So maybe a perfect similar data set is fed to a machine learning model, or a translation model, which can learn through it. And almost similar is also sent through something, and maybe dissimilar sentences are also sent to a learning model to find out, so suppose you have a model which recognizes false positives and false negatives, right? So these sentences could be used to train such models as well, fraud detection types, right? So yeah, so this is how the output is. Now, this is for the text file. Oh, okay, by the way, is the text file flow clear? Or any questions in the text file alignment flow?
Bisal, so you told that like the word embedding is generated into 3D coordinate. Why you are doing that part? I didn't get exactly.
No,
Yeah.
that's being done by Laser and LabSay. We are not doing it.
No, LabC or Ledger, whatever it is, it will generate you the multilingual embedding, right?
Yeah, that's what multilingual. So
Uh,
multilingual embedding in a 3D space, right? At the end
No,
of the day.
no. Why it would be 3D space?
No. So when you have an embedding, that's what I said,
Yeah.
right? Laser has around 500 coordinates. LabSay has around 1,000 coordinates.
Yeah, 1024 and 512, I think.
1024 coordinates, right? So
Yeah.
those are your embeddings. But at the end of the day, when you calculate theta between vectors, where will it lie?
Yeah.
It can't lie in 1024/512 dimension.
I think we can calculate it. That should not be a problem. I don't know here how you have done it, but it should be calculated directly.
Okay.
Because it should be like in general, it should be in the n dimension, right?
Yeah,
So
correct,
you don't need to convert it in 3D or 2D. Means it is
No.
simple a dot product, right?
Correct. True. That's what. So we are not doing any translation between a n-dimensional vector into a 3D space.
Yeah,
Okay.
yeah. So that's why I was confused, like you told
No,
that.
you're right.
Okay.
You're right. It's a n-dimensional space, and we calculate there only. I just wanted to give like a perspective as to
Okay.
how this embedding lies into the space. Like if I say theta between two embeddings, then it might not be so easy to understand, right?
Oh, okay.
So that was the reason. But yeah, it's an n-dimensional vector, of course. Okay. So yeah, that's basically what Laser and LabSay do. Okay, and that is the reason why we use them. And then yeah, so that's with respect to accuracy. So is it clear till now, Pramod?
Yes, Vishal. Yeah.
Awesome.
one more thing. So like we means we have created 3 files. Means one is the like the perfect similar, one is the almost similar, and the third one is the dissimilar. Right. So like the perfect similar can be used for the machine translation or the for any machine classification task. Like in this case, machine translation task. So have you used the almost similar anywhere?
No, so we actually, truly speaking, the similar one also has not been used for machine translation till now. Okay.
Yeah.
We
Okay.
have just used it as corpus. So what
Okay.
we do is, even in almost similar, if there is something that is close to 0.8, right? So for example, if it's 0.89,
Yeah. Okay.
consider it as similar only. The only
Yes.
that is rejected is less than 0.7.
Okay.
Yeah. So that is like rejected, totally not used at all.
Okay.
Okay.
Yes.
So yeah, so that is the okay. So that is with respect to the TXT flow. And then now, okay, so now there is another JSON flow as well. Okay. Now, why did we do that? That was because we wanted to support a workflow based alignment as well. Say, for example, you don't have TXT and you only have PDFs. So at that time, what we could actually do is we could actually combine the power or basically combine the capabilities of two workflows of Anuvaad, right? You can use your digitization flow, digitize your file, and then use tokenization to tokenize it. So now you have two tokenized files and you can directly push it to Aligner for alignment. So we wanted to reduce that dependency of having a TXT file all the time. In order to do that, we came up with this another JSON aligner workflow, which I think Ashwin had written. So yeah, that time I was kind of occupied with a lot of other tasks. So Ashwin took that up and he has written the JSON flow, where you take a PDF and then you pass it through a tokenization kind of workflow and then get the output because tokenizer generates a JSON output, right? So you get the JSON output, and once you get the JSON output, you pass this JSON output to Aligner, and Aligner of course reads through this JSON, gets the sentences out from both the files, and then creates an alignment and returns back in your TXT file again. So that is the JSON alignment flow. Okay. And yeah, so I don't want to go deep into approximate nearest neighbor and all of that. I would rather have you guys do some research on that on your own as to how ANN works and why ANN is used in laser, and why basically how it works and all that, right? So yeah, that is one more thing, because so there is a place where we kind of create a matrix and then optimize the number of calculations that is done. So we kind of create like a global list of embeddings, and we don't calculate embeddings all the time. Once we send both the list, create embeddings once, and only the cosine similarity is calculated at every go. Okay. And then there is a transposition that we do in between. So that's a very interesting thing. So I want you guys to just go through the code and then understand on yourself. It becomes difficult, then of course, like, I'll be glad to help. Okay. So yeah, just kind of read more on how ANN works and all of that, and how you can leverage it in Aligner. So one flow is the TXT flow, another flow is the JSON flow. Aligner could be used in both modes, either as a separate Aligner service where you can just pass your APIs and then get your alignments done, and also use as a part of the workflow. Okay. So you can just kind of define multiple workflows. You have a workflow for Aligner and you have a workflow for JSON Aligner as well. So, but yeah, the difference is that when it comes to JSON Aligner, you need to make sure that you first execute a tokenizer workflow and get the tokenizer output, and only then execute a JSON alignment workflow. Okay. So that is one thing that you have to keep in mind. Yeah, I think this is it. So basically, this is what Aligner does. And yeah. Sorry. Okay, I thought someone asked something. Cool.
No.
No, okay, cool, fine. So what was I saying? Okay, so this is what Aligner is, and then so Aligner is not like a very actively used tool, right? Because it's a corpus creation tool at the end of the day. So whenever we need it, we kind of deploy it in multiple services, multiple pods, kind of scale it up, use it for a week, create as much as corpus that we want, and then we shut it down again. So it's like a need-based use that we do. It's not like live all the time. So I think, and my suggestion would be to continue using it the same way. There is no point of keeping it live all the time and wasting a lot of resources. Whenever you want, just fork it into like 10, 15 containers or so deploy it on multiple machines itself if you run out of your physical CPU memory resources. So just use them as containers and then execute and generate your corpus. So that is the best way. Okay. Now I think I'm not sure how robustly the JSON workflow is being used, but yeah, I think that is one thing that we have to concentrate more on. Right now, it's like a combination of two different workflows, but if possible, if we can create like a single workflow which does both, kind of takes a PDF in the input and finally generates a TXT output, then that would be great. So for that to be done, there has to be enhancements done at the workflow manager end where you have to accept like two files in a single workflow, right? So that enhancements goes to the workflow manager team. So whenever that change is done, I think that would be a very great implementation if you could just accept PDFs, blind PDFs as input and generate a well curated parallel corpus at the end. Okay, so that is one major enhancement that has to be done, which is like a combination of enhancements in workflow manager and aligner both together. So yeah, that is one thing. Apart from that, okay, coming to LabSay laser, right? So right now we have not made any updates to our LabSay model or laser model. As far as I know, the last time I checked, there was no new version released of LabSay. So we have not made any upgrades, but just make sure that whenever a new version is released and it works well with our use case, please keep maintaining it. Please keep upgrading it. Try it out with multiple things and see how it works. Okay. So one problem, as I already stated, was in TMX where we could not find parallel phrases for a given source target sentence. So if a new version of LabSay could fix it, then that is great. Now that is why we have moved from a LabSay based alignment to a attention based alignment in TMX. That is because of the same problem. First thing is we didn't want to use LabSay and our because when NMT model by itself can give us alignments through the attention output, why use LabSay, right? So we didn't want to kind of maintain two machines, two engines as such. So that was one reason. Another reason was there were problems with the LabSay model in itself when it comes to kind of aligning a few phrases. So yeah, if you get like a new version of LabSay, please upgrade it and see if it works better. Then yeah, it will help both the alignment process and also our TMX accuracy. Okay, so that is another part. So yeah, I think this is it about it. Of course, there are a lot of configurations and all of that. I'll just give you a code walkthrough, but I would kind of suggest you guys go deep into it and then kind of assimilate line by line of the code so that it becomes you to do any enhancements in a later point of time. So is this clear? Shall we walk through the code?
Yeah, we should go through the code. Pramod.
Yes, yes.
Yeah, okay.
Yeah.
So I think it is all like in the TMX part, if it is not working, it is because of the phrase. Like the LabSay is for the sentence embedding, not for the phrase or the word embedding, right?
Yeah. So phrase as in there also we'll have there are cases where we have sentences. Okay. So there are cases in TMX when we have sentences with 6 words, 7 words also.
Yeah.
So even in that case, sometimes it fails. And what we actually do there is we also do a tokenize, right? So basically we are not comparing a phrase with an entire sentence. We compare phrase with tokens of phrase. So in that case,
Yes,
of course,
exactly.
it performs better in like 80-85% of the case, but in 15% it does not. That's why we have moved to a attention-based alignment for now. But in latest point, if you find like a better version of LabSay, then yeah, it's a good consideration.
Okay.
Okay, so this is the documentation. Okay, I think this is the one which Ashwin created. Okay, so yeah, I mean, you guys will be maintaining this document, right, Amit and Pramod? So please, I mean, as I've already commented here, just add more data about laser labs, say, add more about how cosine similarity works and why not Euclidean distances and all of that, and explain more on how phase works, all of that. Okay, so that becomes very easy for anyone to understand these. I've already commented, but I don't know if Ashwin had the time to inculcate those changes, but you guys please do it. So yeah, so this is the documentation where you have objects like basically request response format of both the flows. One is for your normal without workflow and one is with workflow. So without workflow, you directly just hit the sentence align API with your two files, whichever files you have, and then you get the output back. Here you do it via the workflow where you pass two files and then basically run your a tokenizer workflow first, and then take that tokenizer workflow and then initiate another what you call sentence align workflow. Okay. So yeah, the request and response format are mentioned here, but again, just give it a try and see if this is updated or not. Because if I see, since the comments have not been inculcated, I don't think that Ashwin has had enough time to update these contracts as well. So please make sure that you verify these contracts and get it updated. Okay, so yeah, coming to our this thing, coming to our controller. Okay, what is happening? Okay, so let's say you have an align file, right? So if you see the code, it's like a standard MVC code again. So this is the same format we follow in all our services: config, controller, Kafka, laser, repository. I mean, it's config, controller, service, utility, and validator. This is the standard flow, repository. And now laser, Kafka, embedder, etc. are the things which differ from service to service. So you have your service. This is the normal alignment service, and this is the JSON alignment service. I had purposefully asked Ashwin to create a different service and not meddle with the existing one, because why to break an existing flow, right? So he has written a separate service. Now, if you guys actually work on it, then please make sure that you kind of combine it into one service and make like two functions just to avoid duplication of the code. Okay. And then you have one validator which actually performs all your validation on the request, as I said. And then you have SRC type. Okay, SRC type is basically type of the input file. If the input file is JSON, you register a job with the JSON service. Otherwise, you just register a job with your normal TXT service. Okay. So validation input, just for example, as to source is there or not, file is there or not, locale, target file, etc., etc. If you want, you can do validations at sentence level as well. Okay. And then this is your register job. This is, I think, for the JSON service. Okay. Okay. Now this is your alignment. Okay, before that, let's go to the Kafka queue. Okay. So if you see, there is a producer, consumer, workflow consumer, JSON alignment consumer, and workflow consumer. Why do we have multiple consumers? Because we don't want to clog a single consumer with all type of requests. We want to keep the pipelines clear. So we want to make sure that all the basic alignment flow comes through the alignment consumer. All TXT alignment flow comes through the workflow consumer. Okay. But yeah, of course, there is one room for improvement here. You can combine both alignment and JSON alignment without workflow into one consumer, both alignment and JSON alignment with workflow into another consumer, right? So that you can do. Right now it is all separate because I wanted this to be specifically separate so that we don't break the existing flow. Okay. So yeah, it's like a normal consumer code. You take your consumer, and then if you see here, your thread begins. What does the thread do? You do service.process. You go to your alignment service. You will have a function called process somewhere. Yeah, so this is your process function. So what does it do? It gets your files, both actual file and your indic file. Technically, there is nothing called as path and indic path. This goes by the assumption that the source is always English. But now Aligner has matured into a state where it can be any two language files, right? So kind of name it accordingly whenever you're doing your refactor, right? And then yeah, so this is how you, once the file is uploaded, you kind of download the file, store it on your local storage, and then read it from your local storage. This is how we do it from our Samba shared storage. And then post that, you do your update job details. What does it do? It basically kind of registers the job, because the register job function starts the job, as in it creates an entry into the table saying the job has started, but you won't know if it is in progress, right? So the process first updates the table saying that the job is in progress. Once the job is in progress, you create like a source and target corpus. What do? You create a list, as I said, right? So you read the file. Once you read the file, you create both the lists. So you read your file and then you create both. When I say corpus, it's basically in rudimentary terms, it's like creating two lists. That's all. So now you have both of these. Once you have these two lists, where did I go? Okay, you have this, right? Now again, if there is some problem, then you say that it could not be done. And now you go to build embeddings. Now build embeddings is a function which actually takes those lists and creates your embeddings, right? So if you go here, you have a function called build index. build index has two lines, one for laser, one for lab say. Okay. Right now we have commented it out, but the right way is to do it via a configuration parameter. Use like a config parameter saying if lab say enabled, then you do this. Otherwise you do this. That should be the right way. But yeah, right now it's just commented out so that you can seamlessly toggle between laser and lab say whenever you want. So you go to the lab say, pass your sentences. Once you pass your sentences, you will get your encoding. So source encoding done, which is nothing but creating embeddings for your source. Then you have a target embedding done, which is nothing but creating embeddings for your target. So you have source embeddings, you have target embeddings, and then you go to this, right? You have created both the embeddings. Now you have calculated, basically, as I said, embeddings are always calculated once. Okay, we don't want to calculate embeddings at every cosine calculation. So yeah, okay, yeah. So these are the embeddings, right? So you have both the embeddings. Once you have both the embeddings, now you create alignment. What do you do in alignment? You basically pass one sentence and then you match it along with all the other sentences. Of course, we do an approximate nearest neighbor here because we just don't want to do it, sentence by sentence, right? It's almost n square calculation. So in order to reduce that, we kind of have a rudimentary implementation of ANN. How is it done? I want you guys to do, you guys to understand. If you really find it difficult, then yeah, of course I'll help you out. But yeah, it's a very interesting use case. So just find out how we do it. And then yeah, so this is your get target embeddings, right? So yeah, so this is how it is. Okay, I have not mentioned it, but yeah, I had usually mentioned it in the comments, but cool, that's fine. So you have a source embeddings. If you see np.array, right? This is your numpy array, and then here are your source embeddings. Then you find distances. How do you find distances? Using a cdist. Cdist is nothing but cosine distance, right? So, and then yeah, you have your minimum index and maximum index. I'm sure we have a function. Yeah, see, this is the function, right? So this is the function for small sentences and large sentences. Okay. So for small sentences, we have a threshold between 0.65 to 0.7, and for large sentences, we have 0.7 to 0.75. That is because, like how Amit just mentioned now, for sentence embedding tools, matching phrases becomes difficult, right? Because embeddings are not comprehensive. Since embeddings are not comprehensive, the match will not work. So all of that. Anyway, because it's always high on data, right? The more data you provide, the better accuracy you will always achieve in these, principally data-driven systems. So for small sentences, this is the threshold. For large, this is the threshold. Both of them should come from configuration. Right now they are hard coded. So please move it to configuration. Cool. For based on small and large. Of course, there is another configuration for length as well. If the length is between 0 to 15 words, it's called as a small sentence. If it is greater than 15, then you consider it as a large sentence. So based on that, you find out which is the minimum cosine similarity and which is the maximum cosine similarity index for this particular sentence. Based on that, whether you say is it a match or is it an almost match? Okay. So we create like two buckets. There was another bucket also of rejected sentences, but I think, yeah, oh, sorry, it's still there. Yeah, see, no match, right? So we have match, almost match, and no match. So there are three buckets that we create based on your cosine index. Where was I? Okay. I think this is it. Yep. Yeah. So this is the key. So this is where we create whether it is, I mean, what do you say? Three buckets, right? So once these three buckets are created, you want to generate an output. How do you generate an output? You have to write them into a file, right? So we have an output directory. Using that, you write the output of your output source, output target. Basically, we create three pairs of files, right? Because you need a pair of match, pair of almost match, and a pair of no match. So you create like 6 files in the output. So this is the function which actually generates your output. Once the output is generated, you upload it to your Samba storage. Once you upload,
one minute. Yeah, so like you have generated three file. Okay, for the sentence pair, for the like the perfect similar thing. So you have taken the like the if the value is greater than 0.9 and the high maximum one, right?
Yeah.
Means if I am getting it correct, like means like you if you have the several sentence and if like the two pair of like a pair of sentences have the score greater than 0.9. So you are taking that one and with the maximum one. It may happen that sometimes with two sentences you have the score of 0.9 greater than 0.9. It may happen.
Yes. yes. Even that's a
Yes.
possibility. That is a possibility. So at
Yeah. So
that time, what
yeah,
happens is whichever is
yeah,
encountered will be taken.
the maximum one, right?
Yeah. By the maximum one. So let's say both of them have 0.95 only. Okay.
Yeah.
At that time, whichever is encountered first is taken.
Okay. Now come to the second bucket, like the almost similar. So
Huh.
in the case of almost similar, the like the threshold value is between like the 0.7 and 0.8 or
Correct.
0.65 to 0.8, whatever it is, the range. So like if suppose in that range we have more than one
Huh.
sentences, then what you have done, like you cannot make the exact pair. Even in that case, you have taken the greatest one or the first encounter.
Yes. Greatest one. Yeah. Greatest one.
Okay, the third bucket you have the not similar. So in that case,
Everything that is
what
left
is the
out.
logic? Means because you have created that those pair of list also, right? So in that
Yes.
case, how will you create the pair?
No, whatever is left out, right? Say for example, now
Okay.
you have 100 sentences. Okay. There are 100 source
Okay.
sentences and there are around 100 to 1000 target sentences. The
Yeah.
logic is you take first sentence and see if this sentence has a perfect match, almost match, or a no match. If it has
Okay.
a perfect match, put it in the first bucket. If it has no almost match, put it in the second bucket. If it does not have any match, then you put it in the last bucket.
Uh, okay. So in that case, the second bucket and the third bucket maybe have the more number of sentences than the exact one, right?
Yes.
Okay.
So that is the thing. Okay. Is it clear?
Me fine. Yeah.
Pramod, are you clear?
Yes.
Okay, cool. So yeah, so you have your source, you have target, you have manual source, manual target, and then finally, yeah. So whichever sentences were not found, then you put it in no match. Okay. So the output generates 5 files. Sorry, not 6 files. It generates 5 files. So you have two pairs of all exact match and almost match, and the last is nothing but sentences which did not have a match at all. So that is the residue bucket that you generate. Okay. So those are the 5 files that come in the output, and then what else is there? I think yeah, after that you have some error and all of that. So this is basically this is basically the state management of the job. When it is failed, when there is an output error, how do you communicate it back, all of that. So yeah, you guys go through, just make sure that you concentrate on these things as well. Even aligner uses log underscore info and all of that, right? So log underscore info, log underscore exception are all coming from auditor. So the same functions are used here as well. Okay, and then build embeddings, get alignments, generate output. Cool. The same thing works here also. Okay. You take a JSON file, you read all the sentences from there. Of course, task ID and all come when it's a part of the workflow, because workflow will need task ID, status, and everything. But if it's not a workflow, it's a normal flow, then yeah, not needed. Yeah, you have your update job details. The update job details is a function which actually updates job status into the DB. And then you build index using your labs. After that, you process, right? So here again, right? See, this is what I was talking about. Here you have your KNN, target embeddings, and all of that. So how does it work? Please go through it. Okay. So that kind of will help you more. And then yeah, so again, like creating a data frame and stuff like that, just to make sure that the process is faster and the output is generated in the required format, because there we also needed alignment score. So yeah, there we just directly do it in a TXT by writing it, creating a CSV and direct dumping it. But here we just create a data frame and then dump it. So that's the only difference. Okay, and again, as usual, error handling functions. So both flow are same. There is no much difference, but yeah, we have just tried to include some additions here to try out, if we can optimize the flow, all of this part. Okay. So this is the KNN that we use here, but there again, it's the same approximate nearest neighbor algorithm. Here it's a K nearest neighbor, and then uh, what else? What else? What else? Okay, yeah, I think that's all. Yeah, so even in this flow, it's the same thing. Okay. So then you come to utilities. Utilities are these functions like you already know. These are commonly used functions. So like parse input file, parsing a JSON file, writing output, reading the output, doing your CS calculation, right? Cosine distances between two vectors. So these are all functions that are these are like tools. Like these are like tools. Whenever you want to use, you can use it. Okay. Like say converting a file to binary. You might use it in multiple places, right? So such things are here. And then validator, as I showed you, has its own validation logic. Repository must have the Mongo code according to me. Yeah. So this is the MongoDB code, right? Where you create job status, search job status and update it. So you do it in both places. Like you do it while it is going through the workflow, and you also do it while it is acting as a what do you say, your separate alignment tool as well. Okay. And then, yeah, Kafka as it is, this is the laser repository where the code for laser is there. Okay. Kind of did a multi-processing and stuff like that just to see if laser performs well. Yeah, so that was one experiment that we did. And then embedder is our lab say code, which all of them is anyway abstracted out. So we didn't do anything as such. So is that clear? If you guys have any doubts, any questions? I mean, of course, you might have a few questions. Just go through the code. So once you go through the code, you will have better clarity. And if there are any doubts, we can again sync up on the same thing. All right. So what do you feel about this, Amit? All clear? Fine to go to?
Yeah, it is fine with me. Because actually, I wanted to see the code, mainly the code part, like how
Okay.
you guys have implemented. Otherwise, the theoretical part is clear to me.
Okay. So the code part, how did you feel? Is it okay for you?
Yeah, it is fine. So, like the KNN, you told, like which are the things you have implemented?
So KNN is implemented in that JSON flow itself. Okay. So that is your
Okay.
K nearest neighbor. Then there is an
Yeah.
approximate nearest neighbor as well. Okay. So
Yeah.
approximate nearest neighbor and KNN is two things that you see. But yeah,
Okay.
yeah, KNN is what. So Ashwin has implemented it in the JSON flow.
Okay. So yeah, apart from KNN or the, so you didn't try other algorithm, right?
No, 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 nothing. So,
Okay.
okay, both ANN and KNN are only used to optimize the calculations. Okay.
Yeah,
So
yeah, yeah.
we didn't want to calculate for every sentence. Like, we didn't want to do an n square calculation all the time. So that was the reason. But if you want to make any change, if you want to make updates, feel free to do it. Okay. Uh, okay. So Pramod, what do you feel? Is everything good?
Yes, Vishal. Previously I've used the aligner.
Oh,
And also I've understood the workflow. It's just that I have to read a bit about the word embeddings, Atlassian laser and the ANN. So, and I will start going through the code and read about them. I'll get back to you.
yeah, sure. I mean, you can reach out to me. You can also reach out to Ashwin in case I'm not available, in case
Yes.
I'm occupied with something. But yeah, both of us should be able to help.
Yes, sir.
So Amit, so what is the plan? So between OCR, Aligner NMT, and IndicTrans,
Yeah, yeah.
how are you guys dividing between you both?
So basically, we both, me and Pramod will be the part of all four. Okay.
Yes.
So, but apart from that, he will, Pramod will handle the task related to OCR,
Huh.
and I will handle the task related to NMT, aligner, and all those.
Okay, so
Yeah, and
IndicTrans.
we had the discussion, me and Pramod before. Yeah.
Okay, fine. So IndicTrans and Aligner will
Yeah.
be mainly handled by you. OCR and OCR content handler will be owned by Pramod, right?
Yes, 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 exactly.
Okay. Yeah. Cool then. That sounds good. So yeah, but yeah, it is better if both of you are aware of all the modules. But yeah,
Yes, yes, yes,
as
exactly.
primary resources, you can kind of distribute
Yeah.
across among yourself. All right. So yeah, so now the documentation is already there, but I want you guys to enrich that document. Okay. So please go through it. There will, of course, there will be some updates required, API contracts, and some extra details. I've already commented on the document. So please add those things as well. Okay. So who is owning up that documentation thing?
So like the means if OCR will means OCR documentation part will be owned by Pramod, and like the aligner and NMT. So these are the update I will do it.
Okay, cool.
Yeah,
Cool.
means, but I will do it slowly. Like means, if I have the time, I will update it. Okay.
Yeah, because see, update it, but yeah, because there has to be a reverse KT of aligner as well. So before that
Yeah,
reverse
yeah.
KT scheduled, I want the document to be updated.
When would be the reverse KT of the aligner?
No, that depends upon you. Okay. So
Okay.
you
Yeah.
guys take a call. When do you want to do it? Okay. But that should
Okay.
happen before, say what, October 6th. First week of
October.
October.
Okay. Yeah. So yeah, I will do it. Yeah.
Yeah. So based on that, you guys plan and you guys tell me when reverse KT is required. I mean, you want to do it. At that time, we can review the document as well.
Yes. 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 Exactly.
Okay.
Yeah.
All right. So this sounds good, right, Pramod?
Yes, yes, Vishal.
Okay. Awesome. So Shriyari, what is the status of OCR content handler KT?
Content handler, I'll start after the KTs of you from Anuvaad and Dulka. When you finish, no, I'll start mine. So till then, I'll be working on some tasks.
Okay, cool. That sounds good. And so,
CR might take a bit long than expected. For content handler and all, we can give it right away.
no, from your end, you're only done with a word detector, right?
Yeah, I started with document digitization. So between your KTs and there was some priority tasks. So currently, I'm doing that.
Okay, okay, fine. Sure. So just plan it accordingly. Okay.
Yes.
Because just make sure that, like before that first week of October, we are very clear on who is taking which modules and they should be up to speed with those modules. Okay. That is very important.
Yes. Okay.
Okay, cool then. I think we are good here.
Yes.
Okay, and just upload this to Drive Dictionary. And then yeah. And by the way, so with respect to the documentation part, so when you guys write the document, right, please check into the same folder where this KT
If video is
okay.
Okay. Yeah.
So that is one norm we are following. So please make sure that it is there.
Yeah.
Okay. Thanks, guys. Thank you for your time.
Yeah.
If you have any questions,
Thanks.
any doubts, please feel free to reach out to me.